Awesome. Welcome. Today we're going to be talking about the latest advancements in MLflow. I'm Corey, and I'm one of the engineering leads developing MLflow on Databricks. I'm also an active contributor to the open source MLflow project. These days, I do a lot of development of GenAI features, and I'm using GenAI to write most of the test cases. I'm joined today by my colleague, Ben.
Hey, I'm Ben. I'm also an MLflow maintainer, work at Databricks. Work on an awesome team of people globally distributed that all work on building new features for MLflow. And these days, I write an awful lot of documentation for MLflow.
Lots of important docs. Fantastic. We have a lot of exciting topics we're going to cover today, beginning with an outline of the machine learning and GenAI lifecycle. After that, we'll provide an overview of MLflow, and we'll explain how it standardizes and simplifies this lifecycle. Then we'll dive into some really exciting recent improvements in the platform with a focus particularly on deep learning and GenAI. You'll learn about what's ahead for MLflow in upcoming releases. And finally, we'll tell you how you can get started with MLflow today. So let's dive right into it, beginning with the machine learning lifecycle. The process of building a high-quality machine learning model and productionizing that model consists of 5 major steps, beginning with data collection. Once you've collected data, you then clean it and use it to prepare a training data set. You then select an algorithm, a collection of parameters, and train a model on that data. Once the model is trained, you evaluate it against test or benchmark data sets to produce performance metrics. And finally, assuming those metrics look good, you deploy that model to production. Once in production, the model receives new data, which you then use to repeat this process and build your next iteration of models. This might sound like a fairly simple 5-step process, but implementing it effectively creates a ton of complexity. The first layer of complexity is that each of these stages has its own set of independent tools that organizations have to connect together. You'll need to connect your data lake with ETL tools, with a variety of machine learning libraries used by your data scientists, TensorFlow, XGBoost, PyTorch. And then once you've built your model, you'll need to bring in evaluation tools like scikit-learn's built-in metrics or a variety of custom functions. And then at deployment time, you need batch and online deployment capabilities, for example, using Kubernetes or other container orchestration tools. But it's not just the tools that are challenging here. There are also multiple personas involved in this process. You have data engineers in charge of the data collection and preparation steps, and then data scientists who do the training and evaluation. And then finally, at deployment time, there are dedicated machine learning engineers in many cases that manage the production deployment. Clearly, this is a much more complicated problem than it initially seems, and it's a problem that just about every organization these days has to solve. Now let's look at how this differs and changes for generative AI. The first thing that we notice is that it's not just data scientists building models anymore. It's also software engineers building agents and applications on top of existing models. It's a very common practice for a software engineer to select a model off the shelf from Hugging Face, OpenAI, or Databricks and introduce a software layer on top of it using a framework like LangChain or Llama Index to produce an agent. That agent is then evaluated and deployed to production. At the evaluation step, generative AI also introduces some unique challenges. In many cases, especially for language models, there is no one formula or algorithm that you can use to evaluate your generative AI agents. Oftentimes, we see organizations need to rely on domain experts, actual humans, to assess the accuracy of the outputs of these agents. There are certain automated techniques, like LLM as a judge, that can also help with this process. And finally, at deployment time, because multi-step complex agents are being deployed rather than just models, production infrastructure for model serving needs to handle that complexity. For example, many agents need access to data and documents stored in an index that's constructed during the data preparation phase. These agents also require the ability to call external functions for search and mathematical computation. So generative AI does introduce some additional complexities, But probably the most important part of this slide is that those 5 phases of development that we saw in the machine learning lifecycle remain for the generative AI lifecycle. And that's really important because a lot of products and a lot of platforms are trying to sell you bespoke workflows for generative AI when your organization is trying to do both ML and GenAI successfully side by side. We believe that the best solution for standardizing this lifecycle is to have a single unified platform that helps you regardless of whether you're a data scientist training models or a GenAI developer building agents. And that's where MLflow comes in. MLflow is an open source platform for machine learning and generative AI. It standardizes and simplifies this lifecycle, and it's compatible with any machine learning library or GenAI framework. And it consists of 4 core components. The first, MLflow tracking, is a framework for model and agent experimentation. With MLflow tracking, you can record all of your model weights, GenAI source code, parameters, performance metrics, and more. Once this information has been recorded, you can search and compare over it to select the best possible model and the best possible agent for production. The second component, MLflow models, is a packaging format for machine learning models and generative AI agents, ensuring stable inference behavior with a consistent API signature no matter where you deploy your model or agent. The MLflow model registry provides large-scale management capabilities for the thousands or hundreds of thousands of models and agents that you're building, including the ability to promote those from development to staging to production and beyond. And finally, MLflow deployments is a collection of production-grade APIs for deploying your models and agents for batch and real-time inference across a variety of production platforms. At its core, MLflow is a unified platform focused on making machine learning and generative AI as simple as possible, whether you're training or fine-tuning models, building GenAI agents, performing large-scale evaluation, or deploying to thousands of customers. MLflow has more than 700 open source contributors, is actively used by more than 3,000 organizations, and has more than 17 million downloads monthly. And now that we've provided an overview of MLflow, let's dive into some of the most exciting advancements over the last year, beginning with our year in review. Last summer, we introduced MLflow deployments for generative AI. This enables your organization to manage access to all of your LLMs at scale and securely. We also introduced an authorization and authentication layer for open source MLflow so that you can operate the platform on any infrastructure of your choosing. In MLflow 2.6 and 2.7, we made it much easier to call your generative AI agents in production by specifying customizable parameters, such as the maximum number of tokens to generate or the model temperature. In MLflow 2.8 through 2.10, we introduced LLM as a judge evaluation capabilities, enabling you to automate the performance assessments of your generative AI agents. You can use a variety of built-in metrics that we've defined in MLflow for you. We also provide a framework for defining your own. And for deep learning use cases, we introduced automated system metric tracking, which we're going to talk about in a moment. In MLflow 2.11, we dramatically improved our dashboarding capabilities in the MLflow UI for deep learning use cases. We added support for logging parameter-efficient fine-tuned models, as well as automated checkpointing of deep learning models to ensure that you don't lose your weights when you're training job crashes. We also made it much easier to build custom MLflow models with a chat interface that you can deploy and compare against one another. In MLflow 2.12, we offer dramatically improved support for tracking and exploring the results of image models. We also made it easy to package and deploy a model from any arbitrary Python script or Python notebook, which is super important for software engineers as they build their GenAI agents. And finally, and perhaps what we're most excited about in the recent releases of MLflow, we introduced streaming inference APIs for any MLflow model and a brand new tracing capability that Ben will be talking about in detail. But before we get there, I'd like to start by covering some of our deep learning advancements in a little more depth, beginning with automated checkpointing for training workflows. It's probably not news to anybody in this room, but deep learning models are often quite large, and they take a really long time to train. As a result, the best possible practice for your deep learning training jobs is to implement periodic checkpointing. By saving those model weights every so often, your job becomes resilient or fault tolerant to crashes in the training job or issues with system hardware. It's also an excellent practice because it allows you to compare checkpoints against one another and continue training from the best possible checkpoint, because performance improvements are not always linear. And fortunately for you, MLflow makes checkpointing really simple. With a single line of additional code in your program for PyTorch, TensorFlow, or Keras, you can periodically capture checkpoints during your deep learning model training. You can also configure this to capture checkpoints every time there's a performance improvement. All of these checkpoints appear as artifacts in the MLflow UI, in MLflow tracking. This is an ergonomic way that you can view all of the checkpoints step by step. And a nice part of this capability is that MLflow also records the performance metrics for each of these checkpoints, enabling you to compare the checkpoints with one another and select the best one for further training or for production deployment. Another capability that we're really excited about is automated tracking of system metrics. So in addition to taking a long time to train, deep learning models are more expensive to train than ever. They often rely on costly GPU infrastructure. And unfortunately, it's kind of hard to make full or optimal use of this GPU infrastructure during your training job. And so it's really important that you have an idea of how effectively you're utilizing your resources to build the highest quality models and reduce your costs. This is where system metric tracking comes in. Beginning in MLflow 2.8, MLflow now offers automated tracking for any training job that you create with the MLflow Start Run API. Simply add this line of code to your deep learning training job, and system metrics are automatically computed and tracked throughout the entire duration of training. These system metrics appear in the MLflow UI in the Charts tab, where you'll see them displayed alongside all of your statistical or model-based performance metrics. You'll notice that we capture these metrics for every GPU in your multi-node cluster, and you can expand any particular chart to get a step-by-step or timestamp by timestamp idea of your system metric performance and of your resource utilization. Another capability that we're really excited about is improved tracking for image model use cases. MLflow's image logging APIs enable you to store the inputs and the outputs of any image model that you're developing or deploying. We offer two APIs. The first, MLflow log image, enables you to record images over time. So as we saw with the previous slides with checkpointing, as you create checkpoints, you can feed in a collection of images or produce a collection of images and store those alongside your checkpoints to get a better understanding of performance at any given interval. The second API enables you to log collections of image, text, numeric, and other data together. This provides a holistic idea of the performance of your model. And the command that you use for that is the MLflow log table API. We're going to look at that one a little bit more closely. Consider a use case where you're developing an object detection model. Your model takes in a collection of images and produces a collection of detected objects. You want to test that model. So you load a collection of test images into memory, and you feed them through your model to produce a collection of detected object labels. With MLflow, you can package up those images and those lists of detected objects as a data frame, and with a single log table API call, record all of that information to MLflow, and the whole thing takes less than 15 lines of code. Again, this information is displayed in the MLflow UI, where you can do an in-depth analysis of any particular image, and you can see the images side by side with that text data. In this case, the lists of detected objects. As you advance your applications, incorporates multimodal modeling, you can add additional fields and additional information to these tables. And as you build multiple versions of a model, you can compare the outputs of every version of that model corresponding to a particular input to select the best one. And finally, and perhaps the most exciting capability that we're excited about, is improved performance dashboarding for deep learning. See, as deep learning developers, we understand that you spend a lot of time visually analyzing model and system metric performance. And you really need the highest quality UI to make this process effective. Beginning in MLflow 2.11, MLflow's dashboards now offer 7 built-in chart types with more than 30 configurations, enabling you to understand your model's performance and compare across model versions. You can drag and drop these charts between dashboard sections to structure your analysis, and you can share every dashboard you build with colleagues to collaboratively identify improvements and move forward to production. Now that I've covered some really compelling deep learning advancements in the platform, I'm going to go ahead and hand it over to Ben, who's going to walk you through our GenAI enhancements.
So while we were improving deep learning functionality, it kind of transitions into what everybody's talking about these days, which is GenAI. And we wanted to make sure, as Corey said, that we have a holistic platform that covers the soup to nuts journey of building and using these things. So we focused at the same time as we were building the deep learning improvements. Our team was working on a number of GenAI features within MLflow that really improve all aspects of that after the training is complete. First one in 2.9, I think it was, maybe it was 2.10. LLM as a judge. So that's basically using a GenAI model to evaluate the output of a GenAI model. We'll get into that in another couple slides where we'll actually look at what that looks like and how to customize them. And later in 2.11, PEF logging support. If anybody in here has ever tried to fine-tune a large foundation model, you'll know how expensive that is and how much your CTO will be knocking on your office door about your cloud infrastructure costs when you try to do that. So PEF allows you to do that. I've done tests where I can actually do it on a fairly large one on the laptop that we're presenting on right now. So it's possible. We wanted to build that support into MLflow, make it easy to use, and allow you to basically leverage your own data in order to provide solutions. In 2.12, model creation from code. We'll also look at some examples of that in a little bit, but it's pretty exciting. 2.13, 2.14, exactly as Corey said. Streaming APIs, this is the chat interface for GenAI. You want to see as each token is generated, the text is coming out, it's streaming output. Looks pretty cool too when you demonstrate it. And the big one that we're going to announce towards the end, you might have heard it in the keynote today, tracing APIs and the tracing UI and how it integrates within MLflow tracking server. Allows you to kind of see what's going on behind the scenes. But first of all, for GenAI, we're going to talk about models and some of the features that we've worked on, improvements that we've done. Biggest one of any of these has got to be models from code. And the way this is different is instead of you using MLflow APIs to sit there and create a PyFunc and then log it explicitly and deal with objects and then wonder where is my code going to live and how do I have a lineage of where this thing was built. This simplifies this greatly with a really high level API where we basically set a model that defines the instantiation of it. And with this API, it's not just for GenAI, it works for anything in PyFunc. And this is basically how you do it. So we can have a file that's, we're naming it here model_code.py. We're defining our model. This is a Python model, PyFunc. And we use the set model API on that actual class definition. And we're going to record that for you. And we're going to log that as part of the MLflow artifact. That is your model effectively. And there'll be some inspections that happen as well to make sure that code-dependent code is included in that. But when we want to actually log that, we can do that from a completely separate file. And we can just define the Python model as a path variable itself. Like here's the location of where this set model instantiation happens, and we'll log that for you. And then you can load it back up again. And as I mentioned, PEF support, this is a game changer. This is something from Hugging Face. It's a really awesome framework. It works with all the transformers models. And if anybody hasn't played with it, I encourage you to look at it. If you're trying to make an open source model a little bit better on your own data, it doesn't modify the underlying foundation model. So it sort of freezes the weights of the model and then adds additional weights on top of that. It's actually in a separate file. So it's much faster. You need much less data to do it. And we allow you to save PEF training with the foundation model if you want, or if you're just iterating and you're saying, oh, I want to test a couple of iterations here. I want to see, is my data good enough to actually train something that's going to be useful? It'll go through and just save those PEF weights for you. So it saves you on massive storage costs if you're iterating and trying like hundreds of different tests. This is kind of what it looks like when we go into the MLflow UI and look at the artifacts. It'll save it as part of a model artifact. And in this case, we're saving the foundational model along with it. But when this video gets to the end, it's kind of hard to see, but it is showing you that it locked basically the entire foundational model, and it only actually did modifications to the additional weights that came out. It's much faster. Did a lot of work on LangChain this past year. LangChain's done a lot of work on LangChain this last year, and we've tried to keep up in step with them and closely working with them to make sure that our improvements and their improvements, everything's kind of working as well as it can. But the big game changer for us, models from code with LangChain, you can just write your chain, your definition, use set model on that actual class definition, and we'll just log everything for you. We've also greatly expanded the number of chain types. It seems like almost every couple of weeks they're releasing a new one, but we're trying to keep up, and we're adamant about our continued support of making it so that you can use the latest and greatest things that are coming from that library. Standardization of the inputs and output types from these models is also a big thing. The industry is moving towards standards. We're trying to do that as well, making it so that no matter where you're calling this model from, it should be the same interface, and simplifying that. So you don't have to think like, well, I have to change this dictionary in this way and add a list here, and we don't want you to do that. We don't want to do that. So we've been working on that. Streaming inference support is big. Interfacing with the chat model, you want to see it return results in real time as it's generating the next tokens. And pretty big improvements to our auto logging feature within MLflow by providing native LangChain support for auto logging. And then we'll see that in a minute when we start talking about tracing, about how that integrates. Transformers. This time last year when Corey and I were on stage, we announced that we had built an interface for transformers. At that time, we played it a little conservatively by sort of allow listing certain types of objects to be stored. We got feedback over a number of months, and we realized we needed to open that up and make it so that, hey, if it works in transformers, you should be able to log it in MLflow. And now you can. So anything you define, so long as it can be put into a pipeline or it can be defined as a custom model, we're able to log it in MLflow now. And another feature that kind of goes along with PEF is that lightweight model logging. So if you're just directly using a Transformers open source model that's existing on Hugging Face Hub, and you're trying a bunch of stuff and you're modifying aspects of parameters that you're using and interfacing with that model, that development process, you could generate hundreds or thousands of MLflow models while you're developing. If you're saving something like DBRX 1,000 times, you're going to notice that on your cloud storage bill. So we allow you the ability to just say, hey, I'm playing around. I want to see the results, the metrics parameters, but I don't want to log 1,000 copies of a multiple terabyte file. So we allow you to just basically turn that off. And then when you're ready to actually use something that'll go into model registry, you can turn it back on, save the model, and deploy it. Eval is another big thing. And it's something that is pretty greenfield when we're talking about the world of machine learning. Historically, supervised models, deep learning, we have some semblance of a way of evaluating numerical results coming from a model. And we can write very simple algorithms. We can use statistics to determine, like, is this good? Is this bad? GenAI with unstructured text, it's pretty challenging to do that. So we want to be able to evaluate GenAI models in a way that humans would evaluate them as well. So there's a bunch of metrics that are baked into MLflow that are fairly industry standard. Some scores depending on what type of model you're building. You're doing text summarization, or you're just doing text generation in general. There's also other things that are added in there with scores like toxicity. Like, is this thing being a jerk to me or to my potential end users? I want to know that. and we can provide metric scores for that. We also open it up to people being able to define their own metrics. So you can custom craft your own, and we'll get to that in another slide. But using evaluation, we wanted to create a very high-level API that makes the process very simple. So you shouldn't have to be reasoning about 5, 6, 10, 15 different metrics and define them all out. Just tell us what model type it is. So you define that within the API call to MLflow evaluate. And if you want to add additional ones that aren't in that base list, you just add them as a list object. So we define a bunch of them, like latency. You want to see how long does it take this model to respond to the request. You can add it in there fairly simply. And when we go to the MLflow UI after calling MLflow evaluate, we actually have a whole new tab on the run view page. And when you look at an evaluation, you can see all of the inputs that went into that, the evaluation scores that came, and there's a bunch of grouping elements within the UI that makes it easy to compare things to one another. If you want to compare a whole bunch of different models against one single input, you can actually just compare it by that, look input to output, or you can look at input by model and by evaluation score. It's a pretty intuitive UI, and it makes it evaluating and determining what direction you want to go with your next iteration of fine-tuning a little bit easier. And custom eval metrics, as I mentioned, the ability to generate your own, so you can define and tell. It's almost like generating a prompt that goes into a GenAI model that says, I have this definition of this particular metric, and here's your rules, your guidelines for how you're going to be evaluating that. And you set some parameters associated with that, tell it what foundational model you want to use. I think in the example here, we're using GPT-4 as the judge to evaluate a different GPT-based model. And after you define that with the Make GenAI Metrics API, you can use that generated metric in evaluate itself. This is kind of how a custom metric would be defined. We're doing something here called professionalism. And we're giving it within that grading prompt what its rubric is for how it's going to score these things. So 0 being casual conversation, maybe not something that you would want for a very formal interface to end users, all the way to the score 2, extremely formal. And your actual evaluation GenAI LLM will use this prompt when evaluating the input that you're getting it to evaluate. And you can set a bunch of parameters associated with it to say, hey, I don't want you to be very creative per se. In this case, we're setting temperature to 0. Another thing that's coming soon is the MLflow evaluation review UI. And this is a comprehensive one-stop shop for evaluate review, where you can get the system metric aspect of evaluation, what we were just looking at. You can see those scores that are appearing, but we can also take a look at human labeled. So you can look at individual ones, and you can look at the feedback that's coming back, and you can apply tags to it. And you can very quickly see what was the thing that I passed in as a simulated user to what was the output. And the integration with this allows you to just iteratively go through and provide your feedback to how you think the system is doing. And streaming, we mentioned before, sort of the chat response. So we've added in both LangChain, in the MLflow flavor for it, as well as just generally in PyFunk, a new API called Predict Stream. Any MLflow users are very familiar with the fact that we have Predict. That was the main synchronous result that you could get from these APIs. And now with Predict Stream, we can actually yield a generator. And that generator can be consumed on your endpoint to be able to print in real time. That's kind of what this is showing. Where actually each of these lines are coming out as the GenAI model is responding to the initial input. So you can get it to kind of feel like a chat model or chat application. The big thing that we wanted to talk about, and this is something that is going to be released very soon in open source MLflow. But after you take your GenAI model, you've gone through, you've trained it, You've looked at system metrics, you've looked at your actual model metrics, you've gone through the process, whether you use PEFT or not for one of these models, and you have something ready to deploy, or ready for internal evaluation and staging. If you're just doing something where you're running a model that interfaces directly with one of these foundational model services, it's not exactly challenging to see what's going on behind the scenes because you just have an input and an output. However, when you're actually building applications with these, where you might be building a RAG system, and you're interfacing with the vector store, you're getting additional data to augment the input that's going to be going into the final LLM. These systems can get very complicated. And if all you're looking at is your input and the output, you're completely blind to the 30 steps that may be happening internally. And I can personally speak from experience that debugging something like that is an exercise in supreme frustration. So tracing is something that is sort of co-opted from the web world. It's been around for decades, and now it's just kind of going, moving to GenAI because we have these systems that are basically doing what web traffic has done for many decades. And it's allowing us to take things called span events. So when we send a discrete packet of data to a service or to an API, we want to know what we sent, what parameters, what metadata was sent along with that request, and we want to know what came back. And this allows us to track that in a comprehensive system that will collect all that data and store it for us. Now, the first integration is LangChain. And the easiest way to start up tracing in LangChain is just turn on auto-logging. That one API call that you have there, that one line, will just enable it, which means every time that you invoke a chain, it's going to be logging that to your experiment. Whatever the active experiment is that you've turned on in MLflow, we're storing it. It's an artifact, and it'll show up in the MLflow UI. And this is a demonstration of it being in the MLflow UI. We have, just like with Evaluate, we have another tab in there now called Tracing. And if you click on that for the active experiment that you're interested in, we're going to show a UI that's going to give you each of your calls that you made. And when you click on the actual request ID, like we just did here, you're going to see a new trace UI that's going to show you effectively a DAG view of what were the steps that happened, what were the dependencies of parent-child relationships within your application. And it'll also show your inputs and outputs for each of those steps and all of the metadata within the UI. There's a number of different ways, kind of run light on time, but a number of different ways to use these. First one, probably the easiest, we have a decorator. You can decorate any function. We're going to capture the arguments that are coming in, as well as the input and the returned output, and that'll create a span event. We also have context managers, which are very similar. You just wrap your code, and you're going to get a context active object that you can basically mutate. So you can call methods on it to set my inputs, set my my attributes. You can set tags on things as well, and that'll handle it within that particular wrapped context. And in the UI, all of these traces are going to be logged, as I mentioned before, to the experiment. And they're all navigable. They'll be safely stored over time. And we have a bunch of client APIs that allow you to manipulate those, search through them, find the ones that you're interested in. And there's a bunch of filter query terms that you can use as well to track down when you have tens of thousands of these things in there. On Databricks, we've done a few different things in addition to what is being offered in open source MLflow. When we call certain APIs to retrieve our traces that have been logged, we render directly within a notebook. So in an interactive environment, you don't just have to go to the MLflow UI, you see it right there as you're generating it. Anytime that you invoke something that would generate a trace, it's going to display directly within a Databricks notebook. And that trace UI is almost the exact one that you would see for looking at log traces. This is especially good when you're just debugging things. You want to test something out, see, like, am I on the right track? What's going on with this trace or with this model? And same thing with search traces. When we search through experiment IDs, and we actually hit that API to return the ones we're looking for with whatever search query terms, we're going to get a data frame representation that is actually interactive. So you click on the data frame itself, and it'll start rendering that trace below it. It's kind of a cool little interactive thing that you can do with table display. And same thing here with the trace view. We can go into the MLflow UI in Databricks exactly as it is in open source. And you get all of your actual logged traces to show up there. Another thing in Databricks, which this one is super exciting, we're actually doing production logging of traces as well. So if you use Databricks deployment services, so model serving, and you're deploying something that has tracing enabled on it, and you configure inference tables to link to that model, we're going to record every access of that model in production. So if you're deploying something where you actually want to keep a monitor on this, which is the big thing that this is for, you can keep track of every access that you have, every question that somebody asked, all the responses. You can debug in production and understand where you might need your next fine-tuning to happen, when you might need to improve your model. So it's a great debugging tool. And this is kind of what inference tables look like. You can load directly from your inference table that's been configured. And when you retrieve that inference table, you're going to have the traces displayed, and the trace UI will actually be an interactive feature on that as well. So you just click on the row you're interested in, you can see the actual trace. So the big question, when can we use this? So on Databricks, you can use it now. It's in public preview. You can enable it and use it to your heart's content. It's pretty awesome. And June 18th is what we're targeting for open source MLflow 2.14 release. And if you want to get started with MLflow today, if you've never used it before, you can pip install MLflow. As of this last week, we also are doing release candidates, which is going to be a week before main release, so you can install those with the ---- pre as well. All right. Thank you so much for your time.